Hello. Yes.
So, good evening, everyone. It's again wonderful to see a full house for the colloquium. So, we have with us today as the colloquium. So, we have with us today as the colloquium speaker, Dr. S. Unnikrishnan Nair, who is a distinguished scientist at ISRO, and he's also the former director of the Vikram Sarabhai Space Center here at Trivandrum, IIST, which is like a sister institution to us, and also former director of the Human Spaceflight Center of ISRO. Dr. Unnikrishnan Nair did his BTech from Kerala, and then had a master's in aerospace engineering from IISc Bangalore, and a PhD in mechanical engineering from IIT Madras, to which he joined the Indian Space Research Organization. So his leadership in various roles at ISRO as director of PSSC, director of the Human Spaceflight Center, etc., has been key to developing India's capability for human spaceflight, a capability that only Russia, US, and China currently have. So, earlier on in his career, he was a mission director for the Space Capsule Recovery Experiment back in 2007, which validated certain critical re-entry requirements of bringing a capsule back to Earth, right? And in 2019, because of this pioneering work, he was appointed as the director of the Human Spaceflight Center of ISRO. And in 2022, he became the director of the Vikram Sarabhai Space Center. Dr. Nair's research focused on acoustic vibrations and structural dynamics. And for his stellar contributions to various aspects of India's space program, he has received many accolades. He's a fellow of the Indian National Academy of Engineering. He's a fellow of the Aeronautical Society of India. And he has been honored with the ISRO Individual Merit Award, ISRO Team Excellence Award, and so on. And he's also distinguished Luminous Award by IIT Madras. So without further ado, it's a great pleasure to invite Dr. S. Unnikrishnan Nair to deliver the colloquium today entitled Gaganyaan and Beyond.
Good evening. I'm audible in the back row. Okay. Dr. Murthy, your director, and all the faculty, staff, students. First of all, thank you for this invitation. It has been long due. Dr. Murthy used to invite me, but then due to some reason or other, it got postponed, and today is the time. It is my first visit to the IISER campus. I was director of IIST, so I see a lot of similarities in terms of campus and its wildlife, because many a time we see wild boars and other things. I understand such issues are here. So I am here today to speak mostly about Gaganyaan. I hope all of you know what is Gaganyaan. And the decision to go for manned space flight was definitely an inflection point in our program, because we were never thinking of sending humans to space. In fact, if you borrow the words of Dr. Sarabhai, at that time, the vision was mostly to have satellite launch capability to launch satellite, build satellite, and then use the application for common man, or to meet the needs and issues, or solving the issues of common man. But at some point of time, but once we mature into making the launch vehicle satellite, and when we see what is happening elsewhere in the world, there is a renewed interest for manned mission, especially not by government agencies, but by commercial entities like SpaceX or Blue Origin. Naturally, the interest is rekindled, and that is how we also initiated the program way back in 2004. So it means just studies at that time, how to, what is the need? Should India go for manned mission? That was the first question. In fact, this question was there in 1960 when Dr. Sarabhai started the space program. Should we go for a space program, or should we use the money for something else? But now we know the benefits, what we reap from the space program. Apart from self-reliance, the type of technologies we develop for ourselves, which we cannot borrow from other countries. Similarly, the manned space program, as we go through the slides, we will see there is a renewed interest in manned program, because it is going to fetch more benefits to humanity. I think I'll use this mic. There is an interference from this. Okay. So I usually say there is a belief that engineers are running the ISRO. It is not so. There are scientists, engineers, and even all sorts of people are there at different levels. In fact, these are, all of them. They are all notable scientists, but many are having a degree in science or a post-graduation in science. And so the degree in science or degree in engineering, it doesn't matter. If you have a clear vision, what you want to do, anything will do. And all of them. In fact, there are more examples we can take. Even Dr. Kasturirangan himself is a PhD in physics. It is not only that, they are all these artists and scientists. We can see many of the artists have become scientists, and then the scientists also can become artists. Chaudhaya, a maestro in Carnatic, he was using violin, but usually violin has got 4 strings. But then that time mic was not there, and for increased range to match human voice and to get reachability to the backside, he added 3 more strings. So it was a necessity, and he was a master in playing a violin with 7 strings. Similarly, we all know about Samuel Morse, but he started his career as a painter. He was a very famous painter. You can see the Gallery of Lowe. It's a famous painting, but then he himself was not able to meet the both ends with the painting. That is how he just switched over to science. And we know Morse code, telegraph, all those things came from that. So we see there are no boundaries. You may be studying science, chemistry, biology, botany. When we did engineering also, there were so many subjects. Finally, we find that all these subjects merge, because there is nothing dividing it. You need to have a knowledge in all domains if you want to excel in like any area, like even if you launch vehicle or satellite. Now space, anything above 100 kilometer. 100 kilometer is called the von Karman line. So at some point we need to break what is atmosphere and space. So there is, loosely they define 100 kilometer. All countries have not accepted this von Karman line, but that is for space tourism. They say if you cross 100 kilometers, then you have gone to space. So there are many issues. Once we are now on Earth, we are all protected by the atmosphere. But when you go out, there is no pressure. The temperatures can go when you face the sun, temperature is very high, it can be 150. But on the other side, when you face the deep space, it can go to minus 100. There are issues with respect to charged particles, radiation. Everything is protected by the magnetic field and the atmosphere. But then we are going to face them. So when we want to go, when you send a satellite, all these issues are, they are not no major issues we can tackle. But when humans are involved, then it becomes a real issue. We need to address each one of them. And this question, probably all of you know it, but many places, many people ask human spaceflight Gaganyaan, where they are going. Many people are asking, are they going to Moon or Mars? Because nobody can just conceive that we are just going and then just making circles. Like the International Space Station, it is just circling around the Earth, balancing the centrifugal and gravity force. And all satellites are doing that. And if you want to have a communication satellite, you go to 36,000 kilometers, where your speed is matching with Earth's rotation, so that your satellite is always above the Earth, so that the communication is possible. So the idea is, if you want to take a satellite or a crew module or an orbital module for the Gaganyaan, first you have to defy the gravity and then go to that altitude around 400 kilometers. But just simply keeping it 400 kilometers, it cannot stay. It will fall back under gravity. So we need to give a great amount of velocity of the order of 7,800 meters per second. So that is done by the launch vehicle. So the satellite or a orbital module in space has got huge energy, and that energy has to be killed if you want to come back. Anyway, this is simple, all of you know, it's Newton's law, but then still, how this Newton's law is getting converted into action in a rocket engine or a rocket motor. Take for example a solid motor. Solid motor has got propellant and fuel. You give the ignition, and it is converted into hot gas at a high pressure. But then that is potential energy, and that energy has to be converted into kinetic energy through the nozzle. So if you look at the nozzle, you can see it has a convergent and a throat and a divergent. And the convergent is subsonic area where you are accelerating. As all of you know, convergent will accelerate. Throat is the place where your velocity is equal to sonic speed or Mach 1. And then a supersonic jet has to have a divergent portion for accelerating. That is why the rocket has a nozzle. So the throat is the place where it is stressed maximum. One side it is very high pressure and high temperature. Other side it is accelerated and very high speed supersonic flow. And that is precisely what happened in PSLV, C61 and C62. We had failures. The PS3 throat, which is made out of graphite, where the temperature can touch 3000 Kelvin, which towards the end of its action time, it yielded and then it failed. That's how the failure has happened. And we started the program, 1957, Sputnik, the space age started. And that is the time ISRO or India also has not lost much time in starting our space program. We started early in 1916 thanks to Dr. Sarabhai and Dr. Baba, and they came to Trivandrum. Obvious, I hope all of you know the reason, because the magnetic equator is moving closer. See, at that time, mostly the studies were about atmosphere, how the atmospheric weather or the winds pattern, temperature. So many weather studies were mostly, atmospheric studies were done by launching rockets called sounding rockets. So such sounding rockets, it can just go to say 100 or 150 kilometers, and it releases some payloads, and that payloads, as it comes down, it collects data and then transmit to ground. So that they are called sounding rockets because it cannot take a payload to an orbit and keep it in the orbit. It can only just take it to an altitude and then bring it back. So we have different types of sounding rockets, and every month we launch a sounding rocket from Tumba. And there are different types depending upon the size and altitude. But then these sounding rockets are beautiful platforms for doing microgravity experiments. If you have any idea, if you want a long duration microgravity conditions of the order of say 1, 2 or 2 minutes, after dropping the payload, as it comes down, it's a free flight. Till it meets the atmosphere, you get a good amount of microgravity condition. So it is offered as a microgravity platform. And this humble beginning, I think you would have heard so many times. You can see Abdul Kalam is sitting here, Sarabhai and Baba, and any river or any major organization. It was a humble beginning. We started there, and it was in a church also. That also hope all of you know, because there was no building at that time. Sarabhai's that personality. He had a talk with the Bishop Pereira, and they agreed upon immediately. They vacated the place, and the place was given for the study or the research in space. But then that humble beginning, 1962, the INCOSPAR, that was the beginning. And then we launched first rocket from Tumba. That rocket has come from USA, and the payload was from France, but launched from here. So the Tumba Equatorial Rocket Launching Station, so in acronym it has become a hub of activities for international activities. That is why this place was dedicated to UN in 1968 by the then Prime Minister Indira Gandhi. So many countries, they could come and do launch from here, and then because of its proximity to magnetic equator. Then we started making SLV, ASLV. They are all what you call as just beginning of launch vehicle, like 40 kg or 150 kg. But the quantum jump was with the PSLV in 1994. PSLV is still there. And then we wanted to have cryogenic propulsion. That is how GSLV came. Then in 2007, we wanted to bring back a satellite because that is the starting point for a manned space program. 2008, Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, and the saga continues. And at some point of time, we started working on human spaceflight. So these are all operational vehicles now, PSLV, GSLV, LVM3, But considering the demand for these small satellites, that is 400, 500 kg, and a fast turnaround time, that means somebody comes and launch in one week time, we have a small satellite launch vehicle, which is an all solid propulsion, which is already developed and is available, which can carry 400, 500 kg. In fact, now private parties in India, like Skyroot, they are also making such rockets. Soon you will be hearing Skyroot will be launching their Vikram launcher, which can have future 400, 500 kilogram. And LVM3 is now the heavy lift vehicle, and that is what we are converting in for Gaganyaan. But there are now very interesting projects approved, next generation launch vehicles. Suppose you want to go to moon or things like that, you don't have heavy lift launch vehicle. And Gaganyaan is only a short duration mission where you go for a week or few days and come back. But if you want to stay there, we want a home in space. That is the Bharati Antariksha Station. That is also an approved one. At the same time, reusable launch vehicle. That is like a aircraft, go to space, do the experiments, come back and land on a runway. This runway is also an approved one at Sriharikota. So RLV can come back and land, and then it can be reused. Similarly, can we use air from the atmosphere? Instead of carrying, a rocket, you carry both fuel and oxidizer. Now, can we take oxygen from atmosphere? That experiment is called this scramjet propulsion. Then this Venus mission is approved because Venus is our neighbor on the other side. So what happened to Venus? So there are theories that once upon a time Venus also life was there, or what is the measurement parameter for finding out what type of life existed. And moon landing, we are going to have the Chandrayaan mission, and also any of these vehicles, space tourism, going to the edge of the space. ISRO has the technology, but we wanted to offer it to any industry or any startup. If interested, they can take. But then in India also, the space, all over the world till 2000, mostly the space was with the government. But in 2000, we see changes, especially in the US. Many commercial entities like Blue Origin or SpaceX, they started investing in space. So it echoed in our country also. So we wanted that also, that many private players should come. For that, ISRO plus additional limb, that is called InSpace, as a regulator, as an authorized agency, where if you have an idea, a novel idea, you can go to InSpace, and the entire ISRO facilities, ISRO manpower, ISRO technology is available to you. Even there are many parties to fund. Even InSpace will fund you. So what we want is an idea. If there is an idea in terms of rocket or launch vehicle or application or anything related to space, you have a single window system. Whereas Hensil is a commercial arm. That is, they just do business. They go get satellite or sell our launch vehicle and make money. So these are the three players in our Indian space ecosystem now. And many of these technologies have dual use. What is given here is only from VSS. Like this, ISRO has got many centers. Many of these technologies, we have a mechanism by which will be given to industry and is available to public. Just example is this microprocessor control limb. So amputees, above knee amputees, there is a blessing. There is a microprocessor which is again derived from the satellite launch vehicle technology. Okay. Okay. So this we had already done trials. So it's a you can see a person, an amputated person, while he was using this and he was expressing so much of joy in getting back his that working faculty. Many things like medical oxygen concentrator during COVID time, many designs were made and given to industry, and many of them are making like softwares like FEAST is a structural analysis software, like you know about ANSYS and others. So FEAST is something which ISRO's accumulated technology converted into a software called FEAST, and it is sold at a very nominal price. When you for ANSYS and all, while you pay for a 50 lakh or 60 lakh, it's only a few lakhs. So there are so many such spin-offs from space which are available. So this is yet another new experiment. Any launch vehicle, once the satellite is injected, the final stage also is in orbit. It's a debris. So the space debris is really a menace. Now what we have done is that PS4, that is the final stage of PSLV, after the satellite injection, we fitted with them a few solar panel extra battery and then provided some more control, and it acted like a orbiting platform for doing experiment. Many private startups, they have done experiment with this, and after the life is over, maybe a few weeks, what we do, we deorbit it and then it gets back to Earth and gets destroyed. So PSLV is a zero debris launch, only satellite is there, all the remaining parts are brought back. And one of the experiments here, what we have done is space, that is cowpea, German is space sprouting in space. You can see the top one. Top one is before sprouting, and right side you can see the just formation of it. Okay, so this is again a starting point for agriculture in space. You can see this is what is there in ISS. It is not for making vegetables for their consumption, but also when astronauts, they are away from Earth, they wanted to see, they would like to see how the plant is sprouting, how sun sets, sun shines, all these things it is taken for granted here, but once you are away from Earth, all these things you are going to miss. So this is part of the ISS, and when we step out to say moon or beyond, we need to have such sections in our space station where they get the experience of earthly experience, and then it gives them a lot of relaxation. And then 2000, what we see is the entry of SpaceX. Till that time, all the launch vehicles were expendable. That means you go up, once the stage is done its job, you cut it off, it falls into sea. Crores are falling into sea, and the second stage will be ignited. Again, it is falling into sea. Finally, the satellite is injected. But then, when Elon Musk came, he came with a brilliant, disruptive ideas, many ideas. One of the most disruptive is, once the stage has done its job, you cut it off, and using the propulsion, bring it back and then make it land on a barge or on a land, refurbish and reuse. That means that stage is available for reuse within a week's time. So this has cut down the cost of access to space drastically. Till that time, in fact, India was one of the lowest in terms of offering low-cost access. But with SpaceX, even SpaceX is offering at a lower cost than us. So this is not only this, there were many such breakthrough technologies. So if you want to survive in this area, what we need is innovation and new ideas. It's not just copying what others have been done. So this is one message. Probably you have a brilliant idea in terms of bringing back a stage, or even bringing back the space debris, or refueling a satellite. So many areas are there. You come out with ideas. So there are mechanisms now in the country. You can have your own business in that. So this is a space or a universe. The size of the universe, I don't have to tell you, so science students, but we know that it is endless, and we are in solar system, and the humans have gone only up to 4 lakh kilometers up to moon. And the man-made Pioneer or even Voyager just only traveled 24 or 25 million kilometers. It is very, very small compared with the size of the whole universe. So what is really holding us back to step out from Earth and go to this place, these farthest places? There are many, many exoplanets where probably conditions like Earth exist, but we cannot go there because of the limitation of technology. The propulsion technology, whatever we use, if you use, it takes months to reach Mars. So you can think of, if you want to go to say somewhere outside the solar system, it's not possible in our lifetime. So we want breakthroughs in propulsion where we can travel faster than, or if closer to light. Even if you travel at the speed of light to reach nearest star, it takes years. So there is a clear limitation in technology. We need more and better technology. So we you know, if you look at now all over the world, drastically many changes are happening. How first of all, the unknown, exploring the unknown, that quest is always there, and then there will be definitely missions for that. And then how the technology from space as well as from other planets can be given to the society. And it is again an important aspect of national security. You know that in war, now the first target is not people, it is satellite. If you can kill or decimate the satellite, the entire country is vulnerable for attack. And what is happening in Iran, where that if they have the satellite information, data is very important. That is what you get from space. And space commercialization, how we can use it for making business. Of course, this is a national prestige and international leadership when we do it for third time, fourth time prestige. But we know that prestige will not last long. Even the moon mission during the 1960s, when they landed, that time there was a spike in terms of prestige, but then it immediately dies down. So this spreading of this human race into beyond Earth, beyond solar system, this is what is happening all around the world, and the technologies are going in that direction. And this is how the space travelers from 1961 onwards. The blue is public, that is government funded, but you can see the yellow one is private. Gradually it is increasing. That means more and more private players are there, and eventually this public will come down, and more private will be sending humans to space. And the SpaceX, they had launched the first private manned mission at the peak of COVID on May 30th, 2020. The entire world was reeling under the pressure of COVID. They had launched 2 gentlemen, they went to space, and after that there are so many manned missions. Till that time, after the grounding of space shuttle, America was not having an access to space, and they were their astronauts were traveling in Soyuz. But then with the SpaceX Dragon, that gap is now filled. The Dragon capsule is designed in such a way that it can go to orbit, or even to moon, or even take 3 or 4 astronauts to moon. And you would have read in papers NASA's SLS program, that is the Artemis program, first man and woman on moon. It is getting postponed, but then this is that SLS, and SpaceX is making the Starship. This will carry humans to Mars, which is made of stainless steel. Usually rockets are made of aluminum, but he is making it out of stainless steel so that he can recover even both the stages. Both the stages he will recover and reuse. The other one will come back and land. So this, the next is, that is the Saturn V, that is 1969. So such huge vehicles are being developed for transporting humans to Mars. So that is the Artemis program, back to moon. You know this Buzz Aldrin and everything, and I got an opportunity to take a snap with him. He is the only person now surviving. Other 2, they are no more. And there is this question, astronauts' mortality. There is always this question is there, because they are going to space. Are they, the death is due to something else like cancer or anything? But you look at the statistical data. Astronauts and cosmonauts, Russian astronauts are called cosmonauts, but there is no such pattern. They are all, as of now, the available data, they are all natural death, either accident or lifestyle death. There is no evidence to say that the space travel is creating an issue. Another question usually I get is, what is the age of an astronaut? So here the answer is there. 18-year-old, she has gone in 2023, and a 90-year-old, he has gone in 2024. So it is not age. If you are healthy, you can fly, and if you are healthy and if you meet some other conditions that you should not be afraid of flying and claustrophobia, certain other requirements are there that will come out as part of the training program. Now we come to Gaganyaan. Now our idea is how we can take a 10-ton capsule to 400 km and accelerate it to 7,800 meter per second, keep it there, and then bring it back and kill at 7,800 meter per second without giving undue acceleration or deceleration to the crew, and make it soft land. So so the best vehicle as far as we are concerned is Mark III. It's a very simple vehicle, 2 strap-ons, solid motor, and there is a liquid stage and cryo. So we are in orbit. So the top portion where the satellite is kept, that is replaced with the Gaganyaan specific structure. That spiky, the top portion is called crew escape system, and inside that we have the orbital module where crew is residing. You can see that is like satellite. That yellow one is the capsule that comes back, whereas the bottom portion is the service module. Both will be injected into space, and after the orbital phase is over, it is deorbited and the yellow part will come back, whereas the service module gets destroyed during re-entry because you don't have to bring it back. So the typical mission is go up, stay there, deploy the solar panel, and you are in a weightlessness condition, do the experiment. After 3-4 days, fire the propulsion system, and then till that time your velocity is tangential to the orbit, tilt the velocity vector by giving a delta V, and you are under the gravity, and then comes back, and 98% of the energy is killed through aero braking, and when the energy is converted into say temperature, and then you need a very thick thermal protection system, and at around 10 km you start deploying the parachute and splash down into sea and then recover. So this is a very simple program. But then way back in 2001-2007, there was an experiment called a space capsule recovery experiment, where a 555 kg payload was sent in PSLV to say 700 km, and it stayed there for 12 days, did experiments and came back. So that actually has given us confidence that we can bring back an orbiting capsule to ground. Similarly, in 2014, we did another experiment where the first flight of LVM-3, we put a full-size crew module and it was taken to 125 km and splashed down at 1,600 km away. And that again proved the concepts like thermal protection system, parachute system, control. So many technologies got proved in that. And you can see this is the takeoff and the splashdown. At that time, the mission director for LVM-3 was Somnath. I was the mission payload director for CARE, and Dr. Radhakrishnan was chairman. And then the capsule finally was recovered by the Coast Guard and handed over to then chairman at Chennai. So this has again added a lot of confidence. But then a launch vehicle, when you convert it into a human-rated vehicle, so we need to add a lot of redundancy into it. That is what is called as human rating. So we were not having any idea what is human rating. So we had to look at the design and add many systems like you add a escape system, make the system quaded, and then increase the reliability. So many attributes were changed and then converted and made the human-rated version of vehicle. And then the crew module where the crew is residing. There are many subsystems like crew system, crew seat, ECLSS, live crew accessories, avionics. So many systems are packed in this, and they will be lying like this with the chest. The acceleration is always normal to the chest, like a child in a cradle. That is the best posture where you can have more, you can take more acceleration or deceleration. That is why typically all these launch vehicles, not like an aircraft pilot, it is like they are lying down with the acceleration normal. So that is the cabin for the crew, and you can see the Apollo capsule which has come back. So it has got a parachute area, there the docking port, and the hatches through which they get in and come out, and you can see the thermal protection that also got charred because of the heating during re-entry. So one of the critical issues is the man-made debris. Recently, the Chinese program, their crew module was, viewport was damaged by a debris hitting, and they were got stranded. But then luckily they are in a space station. They had to send another capsule and bring them back. So this micrometeorite is a real issue. They are flying at very high speed, 8 to 10 kilometers per second. And when they come and hit, it can shatter anything. So we follow a simple principle like a Whipple shield, where you have two shields. The first one, when it is hitting at very high speed, it will split the incoming debris into thousands of small particles. And the second layer, definitely, because the cloud of debris with this small energy will be blocked by the second one. So this design is there in space station, and also in crew module. We need to protect and ensure that the pressurized compartment is not damaged. And similarly, the crew seat. In fact, if you have an idea for a crew seat, that is again something which we can develop. This is the Russian crew seat. Russians, they just believe that like a baby swing, if the body is supported with the maximum area, you get comfort. What is comfort is, when your weight is distributed over large area, you get more comfort. That is what happens when you sit in a cushion. Your body, the cushion takes the shape of the body, and it is distributed over large area. So what they do, the astronauts will be asked to lie down on a this plaster of Paris mold, and their body pattern is taken, and that is converted into a liner, and that is kept inside a metallic bucket, and then for each astronaut they make the liner. So that is how they provide the comfort. But there are other designs, like when a cat is jumping from a height, it will not land with all the four legs. It will do with a delay. Thereby a single big peak can be split into small peaks. So this technology, that is biomimicking, is another option. This also some countries are trying to develop. Can we use such a technology, and then the impact load, can we attenuate the impact load with this? And this I was talking about the safety. That is, the launch vehicle reliability is 0.95 or 0.96 or 0.97. You take space shuttle, 135 flights, 133 were successful, 2 failures. So 0.98 is the success rate. When they started, they know the success rate is only that. That means there will be failures. That is why PSLV at 60, we had 3 or 4 failures. PSLV's reliability is 0.97 or so. So a rocket cannot be made more reliable, but you can always add an escape system, and escape system can be made more reliable. That is how we do. At any stage during the ascent, if anything goes wrong with the vehicle, the escape system will be activated. That will take the crew module away, and it will be dropped, and then using the parachute, the crew module will splash out, and the crew will be retrieved. So the escape system you can always make with 1 order of increased reliability. So this is typically a escape system. It is all made out of solid motors, quick acting solid motors. Solid motors advantage is it is not that complex like a liquid engine. It is quick acting. When the complexity is less, naturally your reliability is more. So this again is a development right from beginning. We had more than 40 configurations we studied. It started with this, and the end design is that. So any design, if it is not a naturally evolved design, if you mimic nature and then adopt it, it is a naturally evolved design. But otherwise, a design has to go through the process of evolution, and that is how we have reached here. And the tests are going on. I am not saying this is the final version. It can even change. But then to test it, we want another small vehicle to take it to the required conditions, and then escape, maybe subsonic or supersonic condition. And also we do integrated airdrop test for the parachute. And tomorrow or day after tomorrow you will be reading in paper. We are getting ready for another test at SHAR, where the parachute system will be tested by dropping from a helicopter. And the test vehicle can take the system to, we have already done one test. You can see the test vehicle. It takes to some 15 kilometers, and then escape system is activated. You are coming back and splash landing down. So by doing continuous testing and then ensuring that the escape system has got enough reliability, we can ensure the safety of the passenger. So you can see the size of the crew module with respect to a person, and this is the escape system. This is what is assembled with the test vehicle. Now another important system is, if you want to provide a condition like this, like partial pressure, oxygen, total pressure, temperature, humidity, all these things, usually on Earth, you have the carbon water cycle and photosynthesis. But then we need to simulate within a closed cabin. That is what is known as the environment control and life support system, which is a very complex system of systems, and it has to deal with food, waste management, urine, so many issues. And again, the space available is very less. So we do thermal and humidity management. There is a mechanical pump that will circulate the fluid. Whereas oxygen for breathing, you need to carry for missions around Earth. And carbon dioxide removal, use lithium hydroxide. This is again another area. If you have a novel method for a continuous use for a space station and all, if you can develop carbon dioxide removal, nutrition, radiation protection, so many subsystems are integrated for that. And in space, it is not zero gravity, it is a condition of weightlessness. Your weight is the reaction on your body. When that body or the platform upon which you stand is removed, you are in a state of free fall. That is called weightlessness. That is simulated by a parabolic flight where an aircraft, all the internal seats are removed and it fly like this. You get around 20 to 25 seconds and you can see there astronauts, they do donning, doffing a flight suit, all sorts of activities they can do. So when the astronauts or the satellite, they are in space, they are in a state of perpetual free fall. And you can see Shubhamshu Shukla making somersault in space. And the Russians, they use a very beautiful symbol system, like a small doll in your car with a string. And when they reach space, that string tension vanishes and it becomes loose. So they know that they have reached. You don't require any separate tension, sensor for that. And also writing in space under zero gravity is an issue. You know the story in 3 Idiots, the pencil versus pen. Unless the pen is with a compressed air, you are ejecting the pen ink out, you cannot write. But there are space pens available, but now they are using Sharpie, felt pen, tabs are there, pencil also can be used. But pencil has a problem, like what he said, if the tip is broken, it can go around, but then they make a special glue where the tip will not break. And the human body, you know, there are so many systems. When we go to zero, see, our body is around 60-70% is fluid, and it is pulled down by gravity. The moment the gravity or weightlessness condition, the fluid will go up, and you have all sorts of difficulties. Distribution of fluid to upper body result in a puffy face. Your face will become fluffy, and prolonged stay in space, your muscle and bone will become weaker. There are so many issues related to man when we are in space. You can see Shubhamshu Shukla on ground and space, how his space has changed. And with the time, because the fluid is moving up, you can even have a bird lung syndrome. So these are all issues addressed in bioastronautics, where what happens to humans in during long duration stay, and what are the countermeasures required for that. So the training or the recruitment program we have selected from Indian Air Force, so we need to put certain conditions. That conditions have to be met by the astronaut trainees. So starting with the 60 candidates, finally we have selected 4 candidates. There we sought the help of even Russian medical experts to screen them. And they have gone for a 1.5 years training in Russia for generic space training. And we have our own astronaut training center coming up. Only partly it is completed, and we are adding more and more in Bangalore, where they will undergo training. There will be so many training facilities we need. You need simulators, you need static and dynamic simulators, microgravity simulation, you have your psychological evaluation, medical test, and your body movements, how fast you can get in and get out. So all these facilities will be available under the astronaut training center. In fact, the Russian training center is a 70 hectares, a huge facility. I got an opportunity to visit that facility. So similar facility we need, but definitely, you know, these Air Force pilots, they are very close to astronauts in terms of the training they undergo, like centrifuge and other things. That is why usually all first flights, Air Force pilots are flying. And our astronauts, they have been given the wings by our Honorable Prime Minister at VSSC in 2024. And we arranged a very huge exhibition of the development of Gaganyaan. And he has spent more than an hour there. And there are extensive test programs like this. This I said, integrated Aryabhatta test vehicle. Then unmanned flights before we go for the manned flight. And finally, recovering the crew. See, Russians and Chinese, they land on land, but we don't have that much of land, so we have to go to sea. The logistics become more complex in sea, because sea you can tolerate a higher velocity, but then you need ships and other things. But now for us, Indian Navy is leading it. with all other Shipping Corporation of India, Indian Coast Guard, they are all sharing their resources like ship, because we need to have resources at many places. One is the landing zone, and during ascent, wherever likely to have abort, where you need to have such a system. So this manned program is also a risky program. It's not that, as I was telling, reliability is only 0.98, or with the escape system, maybe 1 in 1,000. So this particular program in Russian, all the 3 astronauts, they have gone to space, they have come and landed. But when the hatch was opened, all of them were found dead, because of a very simple mistake where there was a pressure equalizing valve. You know, the capsule has a pressure, and you come down at around 5 kilometers, that valve has to be opened and equalized. But unfortunately, this valve got opened in space itself, and the entire the cabin air has gone out, and they were not wearing flight suit. If they were wearing flight suit, you can still survive for 1 hour. So that is, after this incident, it has become mandatory that the astronaut should wear flight suit during ascent and descent. That is the dynamic phase, but flight suit is a very cumbersome. So once you reach in space, you can remove and then get into a short sleeve environment. So when you are suddenly exposed to vacuum, see, your inside is one pressure, one atmosphere, and outside is vacuum. So the entire body will expand. So many the gases in your blood will release. Within minutes you will die. In fact, there was one example where accidentally one trainee, he was in a depressurization chamber. There are chambers where they will be tested with the flight suit, and then he survived. But then that is only test data available. So once there is a cabin depressurization, immediately you are supposed to wear the flight suit and then protect yourself. So that is done by intravehicular activity flight suit. That is the NASA suit. This is a space suit. This is yet another crew module. It always looks like a garment. It has got all features for breathing, even waste management, even providing pressure. Similarly, if you want to go out, then it becomes a more complex one called extravehicular activity suit, which is still more complex. It is it has got a garment for removing your body heat, and then a 16 or 18 layer external one, and there is a mobility unit for moving you away from the vehicle and coming back. So it is again a heavy one. So this is, we are not made it. If you want to do spacewalk or space assembly, you should have this technology. So initially, when during that Cold War time, they were not allowed to have any entertainment in space. They were all having maximum work. But in Gemini 4 mission in 1965, they took one harmonica, one of the astronauts. In fact, they sneaked in one harmonica and they played during Christmas time. They played a music, Jingle Bells, that is the first music. And the control room got angry and they asked why. Then they said, we saw Santa Claus, so we sang the music. But now later on, you can see now SpaceX, there are enough entertainment, music, art, everything is available in space. So this is about the global trend, new generation satellite. You need to manufacture in space. It's carrying from Earth is ruled out. Constellations of small satellite where low latency data you get, like the Starlink, says traffic management because of the issue, space tourism, and many space-based solutions for automation, governance. So multiple areas development is going. This area, that is where we ask the question, what is after Gaganyaan? So we need heavy-duty vehicles. We should have our own space station for a sustained human spaceflight program. We should also look at lunar. We had landed there, but now we have to go there, collect the specimen and come back. That is a precursor for manned mission to moon. So Chandrayaan 4 is already approved, where you go to moon, collect samples and come back. And Bharati Antariksha Station is a 5-module concept. All the modules will be launched by LVM-3. First module by around another 2 to 3 years timeline. And this is really the place where you can do any experiment. If you have any idea, because this will be launched in 2 to 3 years time frame, the idea can be converted into payloads. You can do experiments. It's a great opportunity for this. There are many technologies required for the rendezvous, docking, berthing, MMOD, and many other related technology when we talk about the space station. So this is something we are doing on our own. There is not much collaboration, except maybe for the docking and other systems we will be doing wholly by India plus Indian system available here. And equally important is the robotic arm. We see most of the activities we want to do without the human intervention, so that can be made safer. So robotic arm both inside and outside, where the modules can be docked and then pressurized and then pressure equalization. And there are activities going on. You can carry an inflatable one like an umbrella, fold it, take it to space and inflate it and rigidize it. So that way, an inflatable space station, in fact, one of the modules were attached to ISS and they tested it also for extended time. So this is one area. And at the same time, question is, why not women astronauts? So women also, they are, there are so many people, especially Sunita Williams. There are changes, physiological changes. Likewise, there will be design changes in the suit and the way the personal hygiene management. So these issues will be addressed as we progress. I am sure even civilians also, we need our own protocol, our own permission, our own training program for civilians. Civilians cannot be subjected to the exhaustive training. But these are all, I think, will be, as time passes, will be doing. And this question is there. Now, recently, the Sunita Williams case, recently NASA has come out with their explanation that it was a very critical space travel by Sunita Williams in that Boeing capsule. If they are stranded in space, there is no coming back. Then their life is in danger. But luckily, they could dock to ISS and they could move to ISS and they discarded the capsule and then came back in another capsule. So this concern is there. That is, if you get stranded, how others can help. So one idea, what Indian Space Station, what we have decided is, we will go to the same orbit and same inclination of ISS. So that the Chinese is in a totally different orbit. In space, changing the angle of the orbit is very expensive. You need a huge fuel. But in the same angle, you can go up and down. So we can always seek support from ISS in case if we need a support from any support. And this process, the moon mission process, so many people, they have lost their lives, American astronauts, Soviet astronauts. So they made a plaque and then deposited by Apollo 15. They call us all, they returned the names of all the astronauts, and then this is called the fallen astronauts, and this plaque is still there on the moon. So many people, they have lost their life because of this. And this is, as I was telling, space tourism. You go up, release, come back. So simple thing. Gaganyaan capsule and one stage of GSLV, you can do it. But this is again, any interested startups can approach in space. Technology you can use and then make money. Maybe it is expensive, but then if you have more seats, you can do it. So this is my last slide. So IISER can do a lot in human space mission. First of all, it is a sustained program in the sense that we are going to have more missions. That means it is a continuous program. Bioastronautics as well as astrobiology. Bioastronautics is long-term survivability of humans in space. Astrobiology is the life forms in space. These are all areas where research is required. In fact, Amity University, they have astrobiology. I think that is the only university in the country. You can also develop payloads for Bharati Antariksha stations or Gaganyaan unmanned missions or manned missions. And IISER can offer courses in related areas. It can be online, offline, or even electives or whatever it is. So we need special sensors and special protocols for crew rehabilitation when they come back or even when they go up. So you can be part of that. And collaborative activities, all these Rajendra Institute is having an MOU. In fact, there is a consortium of all 8 major centers here. IISER also is a part of it. So there are many opportunities available for students, research scholars, faculties for contributing to the program. If you have a novel new idea, it will be implemented. So with this, let me conclude. Thank you for your patience.
Thank you.
And I know this topic is not that, it's a dry topic. Mostly it's technology driven. So if you have any questions, you can ask.
Questions or comments?
If I know, I can answer.
Sir, I have a doubt regarding when will scientists go to space
Go
from
to?
India?
Go to space from India.
Yeah.
That is precisely the Gaganyaan program. Actually, we were supposed to go in 2023, but we know due to COVID and related breakup in the whole supply chain in the world and other issues like the technology related issues, there were some delays. The the reason for delay is, we learned from others. There are many safety critical areas. So we need to address those issues, and that we are right now doing. So the first uncrewed mission is, we are getting ready for that. In fact, the vehicle systems have moved to SHAR, and the orbital module and related system will be moved. Maybe this year, second half, the first uncrewed mission, followed by 2 more uncrewed missions, but our astronauts are also getting trained. So maybe another couple of years, our own astronaut from our own, using our own technology, they will go to space and safely come back. So safely is very important. Yeah.
Good evening, sir. Myself Venkatraman. Sir, actually, I want to know, what actually is the process by which you filter out the AF pilots from the Indian Air Force?
Okay,
To be an
filtering out is, first of all, the invitation is open. So those who are interested. First time there were not many were interested. Second time we got some 60. Now we need to look at their many aspects. One is they will be subjected to many tests. First of all, medical tests. They have any medical problem. Like some people are even will be screened out if they have some form of TB, which is acceptable, normal in our case, but not acceptable to space travelers. And you have teeth problem. The teeth pain is terrific in space if you have teeth problem. And you have any fear with respect to claustrophobia or phobia of height and medical evaluation. So there will be different levels of your intelligence, your quickness or alertness, and medical aspects will be evaluated, and then a medical board will look at it, and then they will be shortlisted. So it's a process.
Yes, sir. And I have one more question, sir. You said the Antariksh to
Bharati
Bharati
Antariksh
Antariksh station will be in the same angle as ISS, but slightly upper or lower. But the fact is that it is the ISS program itself is going to end in 2013. So what would be the case?
But this they have been telling from 2020 onwards. Every year now they are again going to extend it.
Okay.
So that way, anyway, that is only one of the aspects. And for us, the natural angle for us to get the maximum payload is also that. It happens to be that. So that is another reason.
Yes, sir. Thank you, sir. And if you have any advices for us scientists, to go to space, what path we can choose like that?
You want to go to space or you want to work in space?
I want to work in space as an astronaut, and yes, sir.
Okay, to become an astronaut, what is required is the resolve to become an astronaut and a basic degree. And then you can definitely, there is a human spaceflight center in Bangalore. You can be in touch with them and you can become an astronaut. There is nothing holding you back. But then there are certain attributes which you need to develop. And there is an Institute of Aerospace Medicine in Bangalore. They offer courses. You can even contact them. But you can in fact be in touch with HSFC for further assistance. And if you are not getting, you contact me.
Yes, sir. Thank you so much, sir.
Couple of other quick questions. Quickly.
Thank you, sir. It was an insightful talk. So currently there are around 16,000 satellites roaming around the Earth, and the number is only going to increase. So satellites serve, they retire and become space debris. So my question is, are those space debris even a concern for us? And
Yes.
if yes, what vision do we have to cure them?
Correct. Space debris is a concern. Recently, I told you Chinese, even before that, a Russian capsule its radiator, manned capsule was damaged by a micrometeorite, and they had to again repair, and then because it was attached to the space station. So the space debris is really a worry. In fact, one of my colleagues who was in HSFC, Human Space Flight Center, he resigned and he started a startup for capturing the space debris. He says with a robotic arm, you can capture it and come back. And there are other concepts like a Japanese concept where there is a net where you collect the debris. But the debris, they are having very high velocity. The energy is so huge. If you, whatever mechanism you go there, you have to invest that much of energy. So there are no what you call as very definite solutions for that. It's a solution open to the entire IISER students too. If you have a bright idea, we need such ideas. But then what we can do, there are other aspects which we can take care of. The debris, there are two parts. One is man-made debris, the second is natural debris from asteroid belt. So you can choose the orbit and height in such a way that where the probability of hit from natural orbit is less. Second is the man-made debris also, they are all mostly in a particular pattern. This 450 kilometer, there the debris density is less. Third aspect what you do is you design for impact, like space station. Space station every day it is hit by so many micro debris, and any debris more than 10 centimeters size is tracked by international countries. They are all tracking it, and the data is available. And you can take an evasive action. You fire the thrusters and move away. You know from far distance itself that it is going to hit. But for less than 10 centimeter, you decide to take the impact. But still, it is a problem. That is why there are international guidelines by the UN Corpus for designing satellites and launch vehicle. Launch vehicle should not leave any debris. You should not do any satellite destruction test in space. In fact, China has done one satellite ASAT, that is satellite destruction with missile, and has created thousands of debris. There was a spike in the debris. We also did, but what we have done it in an ingenious way. We lowered the satellite to something like a 200 kilometer and then hit it. And 200 kilometer, any debris will not stay for more than 2 weeks or so. They will come down and get burned. So this responsible behavior from spacefaring nations also is important.
Thank you, sir.
Okay, the question in the back. Is there a question in the back?
Good evening, sir. So my first question is the follow-up of what you just said. So you said if we have any idea, we can project it to ISRO. What is the procedure by which I can pitch my idea to you or to ISRO?
You can, one way is you can approach in space, or you can, if you have an idea, you can straight away write to the directors or centers, or you can enter into a sort of, IISER can enter into an MOU with ISRO. There are many ways. If idea is there, I will tell you the way.
Okay, sir. The second question is about, you told that SpaceX is bringing back rockets. What is the thing that is stopping us from doing so?
We are doing it. We have a plan which is called Admire, where what I have shown as the test vehicle for crew escape system. After ejecting the crew escape system, that first stage will come back and make a soft landing. Maybe another 1 year or so, we will be demonstrating. And the next generation launch vehicle, where the first stage is a recoverable stage.
So what were the complications because of which we were not doing it earlier?
No, see, there are issues like, first of all, when you want to bring it back, you need propulsion, because already the stage has achieved some velocity. You need to kill it. Secondly, you are going to fire the thrusters to decelerate it as it comes down. The idea, initially it was thought it is not going to be economical because all sorts of things finally coming back. Nobody ever believed that a stage can be refurbished and reused because of it is very, toxic fuel is running through it, how you refurbish. So nobody did think about it, but he had his own solutions, and he is using, at that time it was hypergolic propellant, but now the world over, we are all switching over to green propulsion, like LOX methane or cryogenic propulsion, which are more conducive for refurbishment and reuse. So it is driven by necessity. See, the SpaceX, he is not an engineer or a scientist. So he wanted to start this rocket program. So he asked people, what is the costliest item? Then somebody told him materials. Then what he is, and he is a person who will read. He read and he found out it is not material. Material is only 2%. He himself found out it is manufacturing. So if you make modular system and manufacture mass produce, that is why the concept of Merlin engine and Draco, Super Draco engine, the engine he will make mass numbers like 400 per year. And each stage will be built from that engine. First stage will have 27 engine, second will be 9, third will be 1 engine. So it's mass producing. So the concept of mass production, recovery, and using 3D printing. So many technologies he brought in and reduced the cost.
Okay. Thank you, sir. It was a great lecture.
Where are you?
Yes, here.
Your coordinates? Okay.
So in space, what kind of research you are going to do? Any kind of biological research will also be there while those people in the space?
Yes, that is what I was telling you. IISER also can come out with novel ideas. Department of Biotechnology, they have given some 39 proposals. And ISRO engineers, ISRO centers have given some 17 proposals. These proposals are being now scrutinized. In fact, there's a committee where I am chairing it. They are going through the proposal. You can also give proposal. So it is time now, because any proposal from idea to concept to product, it takes time. It is not that you need to make it with a compact power, volume, qualified for the flight condition. It should be biocompatible. So many aspects are there. So if you have the idea, you can develop it and then fly.
Okay, thank you.
Hello, sir. Thank you. It's about the space debris. If we somehow manage to make it like obviously it is not possible to completely make the degradable with help of degradable polymers. But if we somehow manage to make it partially degradable polymers, so it will be easy to degrade it, right?
Degrade into what? See, the space you convert from one form into another, that also is not going to help you in reducing the number of debris. It should sublimate, you get into nothing. So that is not possible. So primarily for your launch, you need certain attributes for the material, and after reaching there, you want some other attributes by which it has to just vanish. So that is, anyway, I am not stopping you from thinking that. You can come out with idea. You can test in PSLV, poem or somewhere. Any idea. See, this is an area where you need novel ideas. So you develop further on that. But we can give you what type of issues are there, and then each one you address and come out.
Still, somewhat degradation will also work, right? Because if we not after the launch, but before the launch, if we try to construct it with the organic way.
That is why degradation means what? You are converting from one form into another. But the issue, if it is X, it has become Y. But Y is also a debris.
Okay, I think
okay,
we'll
if you
take it
say
up
all the debris, I will have some chemical reaction by which I will make them into a single block and make it more than 10 centimeter size, which can be detected. That is one idea. But then they are all moving at so tremendous speed, you cannot bring them together. And if they meet together, they make multiple debris again.
Okay, just one last question behind.
Good evening, sir. Thank you very much for the talk. Sir, like you said that capturing the debris is the major problem because of the velocity. So how about we decrease the speed, because mostly the debris is metallic, parts of space, satellite. So how about we use magnetic force to reduce the speed, and then capture the debris?
Okay, see, the problem is you need such a tremendous powerful magnet in space to attract such a fast moving body. Okay, so you design a magnet for that, then you will ask for power for magnet. Is it a natural magnet or a electric or a powered magnet? From where you get the power? And I am not discouraging you, but you just do some calculation and see whether it will work or not. This idea is there, can you use some magnet, but all materials are not magnetic like aluminum. Mostly these are all aluminum. Aluminum is not magnetic. So there are other issues.
Okay, sir. And one more doubt, like, are there any ideas or like research in using nuclear energy for powering
Yeah,
rockets?
nuclear propulsion. See, if you want, even you know, our Chandrayaan 3 had only 14 days, one moon day. After that, it was going into moon night, 14 days. There is no power, no sun. But then, unless you have nuclear power, you cannot survive such moon night. Not only that, once you cross once you go away from sun, your energy is coming down, solar energy. So you need a nuclear energy. We ISRO also working on nuclear propulsion, but it has to be away from Earth for safety reason.
So, sir, can you tell more about that? Like, what are the issue facing?
Main issue is you cannot operate it in the atmosphere. You can only operate it outside. As we go out, maybe as you are traveling to Mars or Moon, you should ensure that the Earth is not polluted by the nuclear propulsion. Second is nuclear propulsion also, when you make it, the systems and then conceive it and then converting it into a practical system, that is also not that lightweight. It is also heavy. So this work is just started, but if you are more interested, your neighbor LPSC is working on it. You can have a internship or a project with them.
Okay, thank you very much, sir.
Okay, so I'm sure there are many more questions, but in the interest of time, we have to bring it to a close. Let's thank Unnikrishnan Nair once more for a very inspiring and informational talk. And as a token of our gratitude for this wonderful talk, I would request our Director, Professor Jain Murthy, to hand over a small memento for Dr. Nair. Well, it's not very small, but a memento.
This is something that we would like you to use it, I suppose, for your laptop. I suppose, yeah. And of course, check it out.
Thank you, sir, and thank you everyone for attending the colloquium.